Welcome. This is HDIN Research's strategic briefing on the commercialization of controllable nuclear fusion. As global energy systems face a fundamental transition, we examine the roadmap for what is often termed the ultimate energy, moving from scientific theory to a $40 trillion market reality. Historically, fusion was a state-led big science endeavor. However, the last decade represents a structural shift. We have moved from the multi-decade Soviet and international research cycles into an era of commercial inflection, characterized by the 2022 NIF ignition and recent records in plasma duration. Geographically, the fusion landscape is consolidating into three core hubs. The United States leads in private innovation, while the China-based cluster, which integrates mainland and Taiwan's high-precision manufacturing, leads in centralized execution and long-pulse steady-state records. Europe continues as a multilateral research anchor via the ITER project. Benchmarking national policies reveals distinct strategies. The U.S. utilizes a milestone-based partnership model to de-risk private ventures. China employs a, quote, three-step state integration strategy, focused on manufacturing speed. The UK is carving a niche in regulatory leadership and robotics, aiming for a commercial pilot by 1940. The private sector is now the primary velocity driver. Cumulative private investment has surpassed $10 billion. This capital shift is notable because it is led by data-heavy big tech firms like Microsoft and Google, who view fusion as a strategic necessity for the AI era. Key Western innovators like CFS and Helion are diverging in technology but converging on timelines. CFS utilizes compact HTS tokamaks to reduce costs, while Helion is pursuing a non-thermal direct energy conversion path, backed by a world-first power purchase agreement with Microsoft. China's private sector, exemplified by energy singularity, is moving at a significantly faster project cycle, roughly 4 to 6 years compared to the 15-year global average. This is supported by a domestic fusion innovation consortium that ensures high supply chain localization. While the tokamak remains the dominant archetype at 80% of projects, we are seeing a diversification of pathways. The emergence of HTS magnets is the universal enabler here, allowing for the miniaturization of reactors that were previously the size of city blocks. The market demand is being fundamentally reshaped by AI. Data centers require high-density, 24/7 firm power. Our modeling shows a massive net zero gap that intermittent renewables struggle to fill alone. Fusion offers the energy density of 4 million times that of coal, without the land use conflicts. We must address the prevailing solar-only view, held by figures like Elon Musk. While solar is a vital tactical component, it lacks the footprint efficiency required for concentrated industrial zones. A solar array for a major city requires tens of thousands of acres. A fusion plant requires less than 50. Furthermore, solar cannot easily provide the 1,000-degree-plus process heat required for steel and chemical production. Interestingly, fusion is also the only viable propulsion for deep space exploration, a requirement for the very interplanetary goals Musk champions. Economic viability hinges on the first-of-a-kind to nth-of-a-kind transition. While initial costs are high, we project fusion LCOE to drop to approximately $25 to $30 per megawatt hour by 2050, following the industrial learning curve seen previously in Leon and PV technology. The primary bottleneck is the supply of 2G HTS tape. China currently leads in manufacturing capacity for Rebco tape, though US and Japanese suppliers are scaling rapidly. Mastering this supply chain is critical for national energy sovereignty. Regulatory clarity is a major tailwind. The U.S. NRC's decision to regulate fusion under particle accelerator frameworks, rather than traditional fission rules, significantly lowers the barrier to entry and improves public acceptance by acknowledging fusion's inherent safety. Focusing on the Anhui cluster, we see an integrated fusion village model. By integrating high-precision manufacturing from across the region, including Taiwan, China is positioned to beat international timelines for burning plasma by nearly a decade. The next decade is the, quote, decade of power. We expect 2026 to be the year of engineering validation, followed by the first grid-connected pilots by 2028. By 2035, the transition from research to utility-scale procurement will be well underway. Despite the optimism, risks remain. Physics instabilities and neutron damage to materials are critical severity risks. We recommend that investors focus on enabling technologies, the pick-and-shovel providers of magnets, cryogenics, and AI control systems. In conclusion, HDIN Research views fusion as a civilization-scale asset. It is no longer a question of if, but when and who. The winners will be those who master the HTS supply chain and the regulatory framework first. Thank you for your attention. For depth content market research reports or customized strategic workshops, please contact our team at HDIN Research via sales@hdinresearch.com. We now open the floor for inquiries.